Good morning and welcome back to the U.S. Army's White Sands Missile Range near Las Cruces, New Mexico. This is our post-launch news conference for the Abort 1 flight test, which is a test of the Orion launch abort system. We are going to introduce our panelists here who will have some opening remarks, and then we'll take questions. We'll take questions here from the reporters in the audience and also on the line from the Johnson Space Center phone. With that, I'll introduce Doug Cook from NASA headquarters. He's the Associate Administrator of the Exploration Systems Mission Directorate, as well as Mark Geyer, the Manager of the Orion project at the NASA Johnson Space Center in Houston, and Don Reed, the Manager of the Flight Test Office in the Orion Project Office, and also served as the Test Director this morning. And to his left is the Brigadier General John Reagan, who's the commander here at the White Sands Missile Range. So we'll start out with comments from Doug.
Thank you. Obviously, it's a very big day for the exploration team. It looked to be flawless from my point of view. It's a very complex system. It's the first abort system the U.S. has developed since Apollo, but it's much more advanced. It has more capability, advanced technologies that will be of value to us in the future. We were never able to put any kind of a real abort system on shuttle, but for the future vehicles, this is capability that we'll have and have now demonstrated, and just looked terrific. And I really appreciate the efforts of the entire team, all my management chain, from Jeff Hanley to Mark and Don, and I really appreciate the work of all the industry team, the Lockheed Martin and ATK and Aerojet and Orbital, with Cleon and all of the industry team. It's a tremendous effort to get to this point. It was a complex system. There were some hurdles, and they've been working on this for about 4 years. And so I really appreciate the amount of dedication and focus in getting to this point today, and the proof is in the achievement. It was beautiful. So I'll let them, you want to hear from them because they can talk more details. So I do appreciate all their work. I appreciate the White Sands Missile Range for hosting this and being a part of the team as well. They've done a terrific job. Appreciate all the work by everybody who organized this today. Because it's a big effort too for all the logistics and everything, but it's a tremendous team effort all the way around. So appreciate it, everyone. Mark.
Well, gosh, okay. I had to write some things down because it's such a great day. I'm having trouble keeping my brain focused. Doug mentioned it. An escape system is such a huge part of human rating for systems in the future as America continues to lead in space. So testing those systems out is a huge step for the Orion project itself. Doug mentioned it's been a long time since we've done that, and today the highly talented team showed that we can do it, that we can put these systems together and make them work and make our systems safer for the crew and better for the United States. Doug mentioned already the great team. I also want to call out Cleon Lacefield, a huge amount of work leading this commercial industry team. Orbital, Lockheed, ATK, Aerojet, Honeywell. There's a great team on the NASA side as well, across the major centers, who were a huge part of pulling this all together, and as well as our work with the general here at the Army. A great team. And what's exciting now about the success is that they get to share in that, and they get to look at the great work they've done, and it's obvious to everyone else. One of the things about these tests, we do a lot of testing on the ground. You test motors by themselves to see how they work. You test computers by themselves. But what this test, why it's hard, is you put them all together. You take your computers, you take your attitude control motor, and you decide to accelerate them at 15 Gs and blare them with 163 dBs, and they all got to work. And the team did such a flawless job today. It worked great. And so it's a huge step for us. So I'm done talking, and we'll hand it over to the man of the hour who made it all come together, Don Reed.
Thank you, Mark, and thanks everybody for coming out. I'm too tired, so I didn't write any notes down, so I'll just ad-lib it here. But I'm very proud of this team. Like Doug said, we've been working well over 4 years to bring this together. It's been a very complex joint team from all across NASA and industry. And we all came together. It's a very dedicated, professional team that has sacrificed a lot to get to this point. So my heart goes out to the families and the people that helped make this possible today. It's a great day for the country, for NASA, for industry. And then going back to what Doug said, yes, it was absolutely successful. From my viewpoint, inside the control van there, we didn't see anything anomalous. Everything worked as it was expected. In fact, we actually touched down at quite significantly less velocity than we had predicted. So the performance was just absolutely astounding. And we have a lot of relieved and very happy people out there to see all this hard work that they've done come to fruition. Now we can go get all the data that we were able to collect from this flight, go back and look at our models, validate what we predicted, and take the lessons learned here and apply it to whatever the future abort system is for the next vehicle. So thanks to everybody, and I'm so proud of this team. It's a great accomplishment today.
It's been a great honor and a privilege for our workforce to support this wonderful team whose leadership is up here with me, but who's out there and made this great success happen. We at White Sands have a great history of testing dating back to the Manhattan Project and the first Trinity test site here, V2 rockets, and so we know how important testing is, and it's just great to have this added to our history here, and thank you so much for coming here today. And the Department of Defense, too, we know how important testing is. We, of course, test our weapon systems out here to make sure that they deliver for our soldiers in the field, and we're just pleased to be a part of NASA as well and supporting this test so that your systems prove their mettle in this test and can be used in the future. Thanks very much for coming to White Sands. Thank you.
I just have one go back. It's okay. I did want to say real quick, one quick go back before we go to questions. So Orion is by itself doesn't have much meaning, right? It's part of an architecture. It's part of a system. And we wouldn't be here today without the management and integration of that total system. So I want to thank Jeff Hanley for his leadership of the program and Doug for his leadership at the exploration level, because we wouldn't be here without their guidance and help to get to this particular test. So I want to make sure we talk about that.
With that, we'll start with our questions here. If the media have questions, you can come up to the mic. And if you can, state first your name and affiliation, and then direct your question to somebody if you can.
Yeah, Leonard David with Space.com and AIAA, Aerospace America magazine. Just curious, with all the congressional and political cloud around Constellation, the program, to what degree do you think you can dial back or scale up what you've learned here today? How will it be applied to other systems?
Yeah, I think it's a great question. So there are key parts of launch abort. One, you need to get out of the way quick. Two, you need to make sure that you can steer it so you safely get out of the way. And three, you need to make sure that you have a chance to get the parachutes out. So no matter what the size is, you've got to integrate that system. So I think the key part about this, regardless of the thrust level, is we've shown you can put those disparate pieces together in an integrated system with the computers and everything else and make them work. So I think it's obviously very much applicable to any other system.
Yes, I agree. And the data that we get back, I think there's 700 measurements on this vehicle. and we'll get data back on the aeroacoustics. We'll understand how the guidance worked exactly, although it looked like it was rock solid from where I was. And in materials and advancements in the sequencing and actually being able to drive this vehicle away from something you want to get away from. This is all knowledge. We'll be able to test our models that go in predicting all of these effects. One big question in my mind has been what are the jet interactions with the flow around the vehicle, and so we had the big engines blowing, and we had the abort control motor on top guiding it intermittently, and so we'll get a lot of data on understanding that kind of information. That's one of the bigger uncertainties. So that's all data that we now have that we'll get from this test.
Okay. Do we have another question? Seeing none here, you have one? Go ahead.
Could you, somebody talk about, in an ideal world, how many more tests would you like to carry out before you feel like the system is completely ready and operational? And a secondary question for any of you. I was wondering, could you just describe for us laymen what was going through your mind or your body? What emotions were you feeling? There's a lot riding on this. It all happens extremely fast, and a lot of things have to fall into place correctly. What was going through your mind as all this was unfolding?
Well, I was taking a lot of deep breaths, trying to calm myself down. In fact, I actually started writing down some data in the procedures just to kind of calm myself down. And, you know, we've been there many a times. You know, we've gone through this. We've done these countdowns numerous times, and the reality sinks in, and so the old blood pressure goes up, and you really, it took a lot to say, okay, I can do this. Stay under control here, and so, but it's very exciting time, and it actually was relatively calm, which we had hoped it would, and the reason is because we practiced this over and over. And so yeah, the nerves were really uptight, but everything went great. So I can speak to that. I can talk to the plan that we had. We had 2 ascent aborts that we had planned to do. We wanted to do the transonic abort. That's where we really challenge the thrust capability of the abort motor. And that gets back to what Mark said. That's your maximum drag condition, so you have to have maximum thrust to get the separation distance. So that's how you size the thrust of the abort motor. Then the next one is the maximum dynamic pressure, is where you challenge the structure as well as the ability of the attitude control motor to control the launch abort vehicle. And then we would do another pad abort with the actual production systems to validate the design in a production, in a pad abort scenario. That drives the total impulse of the motor to guarantee you get appropriate altitude and downrange distance. A lot's got to happen, as you saw. So you'd want to validate with the production system that, in fact, you can do everything in the short amount of time you have.
Okay, were there any more follow-ups here? Go ahead.
Hi there, Daniel Novick with KFOX TV in El Paso. I guess a follow-up to that question. So now, is all that up in the air? Are we on schedule to do those other tests? And second of all, for our viewers back in El Paso who aren't scientists and engineers, just explain how difficult it is to have to have a test this successful.
Let's see. I'll try.
Okay. All right. I can start off.
Okay.
This year, we have guidance in our appropriations language that we are executing the program on track with the work that's underway. So this test is a part of that. We have other tests that are going on, and we're operating the program and planning. The planning is in place for test. So that is our direction. We do have the President's budget request for FY11 that would change our programs. So we're working right now between the administration and Congress on what resolution is on the path forward. So that's yet to be seen, but the planning is in place. All these types of tests are very important. The various conditions that Don talked about, you want to test in all the critical conditions going down the road in developing launch systems in the future, and you're going to need to do those kind of tests. One hard one though is doing the test at ground zero, or from the ground, and getting the crew back under chutes. That's a big test. This condition that you saw today is really a very critical one, obviously.
Just as far as how often are tests successful like this? I mean, it went so well. How lucky do you get to be?
It's hard to predict how well tests will go. That's why you do them. You're testing out things in order to make sure you understand them. And so, but a test like this that goes this well is just a tribute to the hard work and thinking of every possible angle of things that might go wrong. And that's a tribute to the team that has worked through this and worked out bugs in the system, worked out hardware issues along the way, and it's just preparation. But there are still unknowns in testing, and that's why you do the test. So you can't predict, but you see what a good team can do.
Any more questions? Here.
Steve Ramirez with the Las Cruces Sun News. Just wanted to ask, particularly Don, I was interested in this. The winds seem to be up here a little bit today, and I remember in a briefing about a week ago, 10 days ago, someone had mentioned that wind is the worst enemy. Wanted to know how that factored into today's test at all. Secondary question for the panel is, if you could, can you try to put into perspective how monumental, I guess, this type of success was for the test today, and what it means to the NASA program?
Okay, so on the weather, Steve, we've had the weather working against us from day one. Being out here, you've seen the snowstorms you guys have gotten, the wind storms. We had a Category 1 level hurricane here. I mean, we had winds in excess of 80 knots. So the weather has not been our friend, but it was our friend today. And so, yeah, we had some challenges early this morning in terms of getting our thermal protective cover off. We were right at the limit, but we were able to successfully do that. And then for some reason, I mean, the winds right about an hour before launch, the upper level winds just almost went calm up to about 12,000 feet. And so we had rehearsed this quite a bit the last couple of days, and we've had many meetings with Mark and his mission management team, going through and rehearsing, what is an acceptable risk for these winds, because we knew it was going to be a challenge. And we had a few exceedances in our wind placard when we first started, and by the time we got to launch, we were green all the way up. So the weather gods were with us today.
I could say relative to the importance of the test. So relative to the launch abort technology, obviously was very important for that. It got us the next step of saying we can put these complex systems together under high loads, high acoustics, and they perform. So it reduces the test we need to do forward relative to that. But I think it's bigger than that. There's a lot going on in Orion and in Constellation that you don't see because there's no fire and smoke. Right, we're welding a crew module at Michoud in Louisiana. Right, we're flying an rendezvous and docking sensor on the shuttle later this year. We're firing a first stage later this year. We're going to do. We finished our preliminary design for software. All those are key things that people are killing themselves, working hard every day because they believe America should be a leader in space. So a test like this, which goes great and is visible, I think really is a great encouragement for the team in talking about a very visible success for the team. So it helps as far as morale in that sense too.
Okay. So we have another question here. Mute the phone.
Steve, I may add to that, one of my favorite quotes is from Otto Lilienthal, who's a German pilot that actually died flying one of his own planes. And he said to design something is nothing, to build it is not much, to fly it is everything. And so, like I said, the proof is in the pudding. And this is where it all comes together. And that's what makes this such a monumental success, because this system survived in the flight environment and everything worked as we predicted that it would. So that's a testament to our ability to use our analytical tools to predict what we expect to happen. The testing that we do all comes together and gives us high confidence that it's all going to work as a system. So we get a lot of confidence in our ability to make sure we're successful.
Next question? Anyone? With none here locally, we'll take a couple calls on the line. I understand that Mark Kirkman is on the phone.
Hi, can you hear me?
Yes. Okay, go ahead. Okay, go ahead. Try again, Mark. Mark, are you on the line there? Let's go ahead and try the next person online, Tariq Malik, please.
Hi, this is Tariq Malik from spaceflight. Can you hear me?
Yes. Go ahead, Tariq.
Thank you. My question is for Mr. Reed. You mentioned that the capsule landed at a lower rate than you expected. I was just curious if you could go over those numbers for us at this time. You know, how long was the flight? How far downrange? What was that rate of landing on parachutes, and how did that stack up to your expectations? Thank you.
Yeah, so in terms of the performance and the trajectory, we went about 6,900 feet downrange. So we actually went a little further downrange and a little higher than we predicted. In terms of the touchdown velocity, we had predicted out to 97% probability that we'd land at 33 feet per second on the 97th percent high side. We actually touched down at 24 feet per second. And so that's good performance. It shows good performance of the parachutes. And I think that answers your question. Was there one other part there?
How long was the flight?
Oh, yeah, the flight was it was a minute and 35 seconds to touchdown, and we had predicted a minute and 39 seconds. So pretty darn close to what we predicted.
Do you have another question, Tariq?
Thank you. Yes, my follow-up was just, I'm curious, given the performance that you saw today, what an astronaut or a crew would feel, I guess how tough of an escape it would be on them, given the G-forces that you saw today. Thank you.
And so I'll caveat that by saying that this is a high-thrust motor. The design we were going to was actually going to be a lower thrust motor, but for today's test, given the temperatures that we launched this motor at, they would have seen 16 Gs. So somebody like myself that weighs about 200 pounds would have weighed 3,200 pounds under that 16 G load. And so we hope to get that down to closer to 10 to 11 Gs in the next generation Abort motor.
In fact, that's the design we've gone to, is
Right.
reduce thrust Abort motor to get those Gs down. Yeah.
Right.
Okay, Tariq, did you have another question?
That's it. Thank you very much.
Okay, thank you. We'll try back. Is Mark Kirkman back on the line? Mark, are you there? Okay, are there any follow-ups here locally?
All right.
No?
Sir.
Steve Ramirez with the Sun News again. When do you come back?
Soon, I hope. We're working the plan.
Okay. Thank you, gentlemen, for joining us today. Thank you all for tuning in. That will conclude our briefing this morning.